So I just wanted to start by thanking the organisers for inviting me to present some of our research today. I've been asked to provide an update on what is going on in the world of oxytocin in Prader-Willi syndrome. So most of you will probably have heard of oxytocin, and many of you will know of it as a hormone that plays a vital role in childbirth and in breastfeeding, but it also works as a neurotransmitter, which means a chemical in the brain, and plays a role in a variety of functions that also happen to be impaired in people with PWS, some of which are listed here. So evidence for an oxytocin abnormality in Prader-Willi syndrome first came about in the mid-90s. There was a researcher from the Netherlands who looked at the oxytocin system in the brains of 5 individuals with Prader-Willi syndrome, obviously post-mortem, and found a significant reduction in the cells that produce oxytocin in a specific area in the brain. And this study has since been replicated with another 4 people with Prader-Willi syndrome. In addition to that, nectin, which is one of the genes located in the PWS critical region on chromosome 15, mice who are missing this gene showed that same reduction in oxytocin-producing neurons. So taken together, these studies, and particularly that first post-mortem study, led researchers to wonder whether administering oxytocin may help alleviate some of the symptoms. And to date, there have been 5 clinical trials of oxytocin in Prader-Willi syndrome. My conclusion of the findings of all the studies combined is that the results weren't as promising as we'd originally hoped. Some of the studies do suggest positive change, but it's unclear whether the statistical improvement would lead to any meaningful differences or meaningful improvements for the lives of people with Prader-Willi. This doesn't mean that oxytocin won't work, it just means that maybe the type we've been giving or the dose we've been providing is not ideal. It also suggests that maybe we need a better understanding of the exact nature of the oxytocin abnormality in Prader-Willi so that we can make sure that the intervention that we're providing is specifically targeting the problem. And that is what I'm working on at the moment with Professor Stuart Einfeld, and we are working with Sue Carter, who's a professor of biology at the Kinsey Institute at Indiana University, and she's spent the last 30 years studying oxytocin, and she has a couple of theories as to why she thinks the clinical trials weren't as effective as we'd originally hoped. So her first theory is around the form of oxytocin. So as I mentioned, post-mortem studies suggested a deficiency. However, Sue conducted a study, and another group also conducted a study where they looked at the oxytocin levels in the bloods of people with PWS, and they found that they were higher, which is obviously inconsistent with the idea of a deficiency. So the oxytocin levels were higher in people with PWS compared to controls. However, both these studies use an assay that measures oxytocin, the 2 different types of oxytocin combined. So when we produce oxytocin in our brain, it's produced in this 12 amino acid inactive extended form, and it basically hangs around like that until we need to use it. And then it goes through a cleaving process where it's turned into a 9 amino acid active form. And it's this active form that binds to the receptors. And MAGL2 is another one of the genes located in the PWS critical region, and mice who are missing this gene show a reduction in this 9 amino acid active form. And so Sue thinks a similar thing may be happening with people with Prader-Willi syndrome. They're producing oxytocin, but there's something going on during this cleaving process, which means they don't have enough of the active form, and the blood levels are actually representing too much of that inactive form. Up until recently, it wasn't possible to measure the 2 forms separately in bloods of people. However, Sue's colleagues found a way to do that, and so we're currently working on a study to look at those 2 levels to see whether there's too much of the inactive and not enough of the active. And if there is, then the intervention that we may be looking at would be promoting that cleaving process, which, as Alex mentioned, there's a couple of theories as to why the hormones may not be cleaving properly. The other theory that Sue has is around receptors. So the oxytocin or chemicals in our brain work like a key, and the receptors are like the lock. And to date, we don't know what's going on with the oxytocin locks in the brains of people with Prader-Willi. However, there was a study that found that people with autism who have a duplication in that same PWS critical region on chromosome 15, their oxytocin receptor gene is methylated, which means a methyl group is attached to the receptor, to the gene, stopping it from expressing and suggesting that these specific individuals with autism may not have enough receptors. And so we're going to look at whether this may also be occurring in people with Prader-Willi syndrome, in which case the intervention may be looking at trying to remove that methyl group from the gene. So that's one of the studies that I'm working on at the moment, and we're currently recruiting participants. So we're looking for 30 people with Prader-Willi syndrome and 30 age and gender matched controls aged 13 to 30, and we're inviting them to come for a single 2-hour visit to Sydney or to the Royal Children's Hospital in Melbourne. And at the visit, we'll be asking the participants, people with Prader-Willi, to participate in some cognitive assessments, a quick ECG, so heart rate, and to provide a blood and saliva sample. And it's the blood and saliva sample that we'll be using to look at Sue's different hypotheses. So we would ideally like to recruit all of the participants for this study by the end of the year, early next year at the latest. So if you know anyone who may be interested, please let me know, and I'll put my details up in a sec. So the other big thing that's happening in the area of oxytocin in Prader-Willi is carbitocin. So oxytocin is the hormone or the neurotransmitter that we naturally produce. Syntocinon is a synthetic form that is identical to oxytocin, and that has been used in most of the clinical trials so far. And then carbitocin is another synthetic form, but it's designed to be slightly more selective than oxytocin. So oxytocin as a hormone first evolved from a genetic mutation from vasopressin, which is another hormone. So vasopressin and oxytocin are both hormones we produce that are very similar in structure, which means oxytocin binds to its own receptors, but it can also bind to vasopressin receptors. And vasopressin is associated with aggression, amongst other things. And in the clinical trial that we conducted of oxytocin, we found that people who were given a higher dose showed an increase in temper outbursts. And one theory as to why this might have been happening would be because the oxytocin that we were giving them was binding to vasopressin. So carbitocin is designed not to do that. It binds specifically to the oxytocin receptors, and it is also supposed to have a longer half-life, so remain in the brain slightly longer. To date, there has been one phase 2 clinical trial of carbitocin in Prader-Willi, and it involved 17 people who were given carbitocin, not oxytocin, and 20 who were given a placebo. And this study, because it was phase 2, they were predominantly looking at safety, and they found that carbitocin was relatively safe when given 3 times a day for 14 days at a relatively low dose. They did some preliminary analysis on effectiveness, which suggests that carbitocin may help reduce hyperphagia and obsessive and compulsive behaviours. However, given the small sample size, the main conclusion that can be drawn from this is that a larger phase 3 trial is needed. And the people who own the rights to use carbitocin in Prader-Willi is Levo Therapeutics, and they're currently running a large phase 3 clinical trial in the US and Canada. And they are thinking of bringing it to Australia. There's a lot of logistic issues which may prevent it from happening, but if it does happen, Stuart and I may look at setting up a site in Sydney, but we only want to do it if we think it's something that's of interest to parents, because setting up a trial is very timely and expensive. So this one would be looking at recruiting people aged 7 to 18 years, and it would involve attending study site visits 10 times over 16 months, which is quite a big commitment, but it is a within-subject design, which means that every child who participates will get to trial the carbitocin at some stage over those 16 months. So these are my contact details if you're interested in participating in either of those studies. And I'm just going to quickly pop in one more study because we're running it in Queensland. So in addition to oxytocin, the other thing we've been looking at is GABA, which is another neurotransmitter. And GABA is the major inhibiting neurotransmitter in the brain, so it turns off the activity. We didn't originally think GABA was involved in Prader-Willi syndrome because although there are some GABA genes in the PWS critical region, they're not imprinting genes. However, we've since shown that there is reduced expression in those genes. And we recently conducted a study where we use mass magnetic resonance spectroscopy, which is a relatively new neuroimaging technique that measures brain GABA levels. And we measured GABA levels in 15 people with Prader-Willi syndrome and 15 controls, and found that individuals with PWS who had significantly high levels of behaviour problems had significantly low levels of GABA. And this was compared to the typically developing controls and compared to the people with PWS who didn't have high level or who had sort of moderate behaviour problems. And the behaviours that were most often associated with GABA were like social difficulties, a tendency to be self-absorbed, so autism-like behaviours, as well as temper outbursts and depressive behaviours and skin picking. So we are interested in sort of extending this research, and there's a lot of money being invested in trialling GABA modulators in other developmental disabilities, particularly autism, Fragile X syndrome, but also Angelman syndrome and Rett syndrome. But unfortunately, these companies aren't investing in Prader-Willi yet, purely because we don't have enough evidence to show that there is a GABAergic disturbance. So in this new study, we would be conducting it at the new Brain and Mind Centre up at the Sunshine Coast University, and we'd be recruiting people aged 18 and over with Prader-Willi. And what we'd be doing is giving them, scanning their brains, giving them a GABA modulator, and then scanning it again. And what we'd be looking at is whether they show a different brain response to the GABA modulator, as has been shown in autism. And if we find that is the case, then that would prove that there is a GABA disturbance that's similar to autism, and it would help attract attention of pharmaceutical companies. Thank you. Sorry, I talked really fast.
Thank you, Lauren. We wish you every success with your research. To all of you.